Hello and welcome to this data science project. In this project we are going to perform mortality prediction in ICU using artificial neural networks. Let's start with introduction. Patients admitted to the ICU suffer from critical illness or injury and are at high risk of dying. ICU mortality rates differ widely depending on underlying disease process, with the death rates as low as 1 in 20 for patients admitted with following elective surgery and as high as 1 in 4 for patients with respiratory diseases. So here 1 in 20 patients die who are admitted for elective surgery and 1 in 4 patients die with respiratory diseases. It is 25% death rate. The risk of death can be approximated by evaluating the severity of patient's illness as determined by important physiological, clinical and demographic determinants. In this deep learning model, we will be using artificial neural networks to predict the mortality rate. We will first perform exploratory data analysis in order to understand which of the given parameters are playing an important role in determining mortality and neglect others. Once the exploratory data analysis has been completed and we have created our final data set, then we will split into two sets, test set and training set. Our deep learning model will run on training set and it will be tested against the test set. The accuracy will be measured and attempts to improve will be taken. Let's start with importing important libraries. First we import warnings and then warnings dot filter warnings ignore. If you have not updated any of your library, it will show us warnings. So in order to ignore that warning, we have imported warnings and we have done filter warnings. Then import numpy as np. Numpy is a general purpose array processing package. It provides a high performance multi-dimensional array object and tools for working with these arrays. It is the fundamental package for scientific computing with Python. Then import pandas as pd. Pandas is especially designed for data analysis and manipulation. Panda is used to load our datasets. And then import math. Math provides access to mathematical functions defined by the C standard, which includes trigonometric functions, representation functions, logarithmic functions, etc. And from sklearn.metrics, import accuracy score. Now we are importing accuracy score from sklearn library. So accuracy score is to compare the score between our actual values and predicted values. And then from sklearn.model selection, import train test split. So we are importing train test split to split our training data and test data. And then we are importing Keras. Keras is a high-level neural network API written in Python and it is capable of running on top of TensorFlow or Theano. It was developed with a focus on enabling fast experimentation. Now for visualization, first we import matplotlib.pyplot as PLT. Matplotlib is a visualization library in Python for 2D plots of arrays. Matplotlib is a multi-platform data visualization library built on Python arrays and designed to work with broader SciPy stack. Next we import Seaborn as SNS. Seaborn is a high-level visualization library %matplotlib inline. We use this in order to plot our graphs in the cell itself. And then sns.set_style white. So for Seaborn heat maps or plots, we are setting style as white. Now let's run this cell. I'll press Shift Enter to run this cell. So now we have successfully imported all our important libraries and now we are using TensorFlow backend. Now let's see our dataset in our computer. So here we have train.csv file, labels.csv file, and this is our Python notebook. Now let's import our data. First we are importing train file. So for that, df is equal to pd.read underscore csv train.csv, and encoding is utf-8. So here we are importing our csv file using pandas, and we are storing it in df. So here our train.csv data frame will be stored in df. And let's run the cell. I'll press shift enter to run the cell. Now let's import our labels. For that, labels is equal to pd.read underscore csv, and here we are importing labels.csv file, and encoding is utf-8. Let's run the cell. I'll press shift enter to run the cell. So we have successfully imported our training set and labels. So these training set is our features, and this labels files are labels which we need to predict. Now let's perform some exploratory data analysis. To check top 5 rows of our data frame, let's type df.head, and I'll press shift enter to run the cell. So here we have ALP, ALT, AST, age, albumin. So these all are our features, and we have cholesterol, temperature, urine, WBC, weight, and pH value. So these all are features. With the help of these features, we need to predict our labels. Let's proceed further. So to check all the columns present in our data frame, we need to type df.columns. Now let's run the cell. So it shows all the columns which are available in the data. Now let's see the shape of our data. For this, I'll type df.shape, and I'll press enter, shift enter. So here we have 3999 rows with 42 columns. Let's check the info of our data. So for that, type df.info and press shift enter. So here it shows type of our data. It is float 64, float 64, int 64. So these all are the names of our columns, and we don't have any missing values also. Let's check mean, median, and average of our features. For that, we have to type df.describe. Let's implement this. I'll press shift enter. So here we have minimum as 12 and maximum as 1472, and top 75% is 82, and top 50% is 77, mean is 89, and total count is 3999. So similarly, we have maximum age. So patient's maximum age is 90 and minimum age is 15. So there are patients of 15 years of age who are admitted into ICU, and maximum age is 90, and top 75% are of 78 years of age, and 50% are 67 years of age, and 25% are 52 years of age. And the maximum weight of our patients is 300. So that's very horrible. I mean, 300 ages. Now let's check the shape of our labels. So for this we need to type labels.shape and run the cell. So the shape of our labels is 3999 rows and 1 column. So let's see our labels. So this is row number and this is column. So we have 0, 1, 0, 1, died and not died. Now in labels we have in hospital death. Let's see the value count. So we have 3445 of 0 and 554 cases of 1. So here 0 stands for no death and 1 stands for death. Now let's do one-hot encoding. One-hot encoding is a representation of categorical variables as binary vectors. In some cases, a deep learning model appears to become biased with inputted categorical variable. In this case, we have death or no death scenario. Hence, we need to encode these values. One-hot encoding encodes the data in a manner which ensures zero bias. In this case, we know that death is denoted by 1 and no death is denoted by 0. After one-hot encoding, death will be denoted by 0, 1 and no death will be denoted by 1, 0. So here first we create an empty list, temp is equal to empty square brackets, and for I in labels is equal to 0, which is for no death, temp dot append 1, 0 and else temp dot append 0, 1, and then finally temp is equal to np dot array temp. So we are converting that list into np array. Let's implement this. I'll press shift enter. So we have successfully completed one-hot encoding and converted that list into array. Now let's print the shape of one array. So now we have 3999 rows and 2 columns. Now let's concatenate our features and labels. So now new is equal to pd.concat df comma labels. So in df we have features and in labels we have our labels. So till now we have separate features and separate labels. Now we need to join them and x is equal to 1 and then we'll print shape of our new data frame. Let's do shift enter. So now we have 3999 rows and 43 columns. 42 columns are of features and 1 column is of label. Now let's use correlation map to find out important features and then relations with the features. A correlation heat map is used to study correlation between the given parameters of a dataset. Let's implement this code. So here correlation map is equal to new, in square brackets we have new dot columns. So new dot columns gives all the column names which are in new data frame. So these all columns will be in the form of strings. So new is our data frame. So it's like df of column name dot correlation. So all columns dot correlation. So object is equal to np dot array correlation map object np dot trill and underscore indices from object is equal to false. Now fig comma ax is equal to plt dot subplots fig dot set underscore size underscore inches 25, 18. So this is our figure size. Now finally let's create an heat map. So sns dot heat map Here we are using parameters as correlation matrix, which is correlation map, mask is equal to object, Vmax is equal to 0.7, square is equal to true, and anode is equal to true. To see what are the total parameters that can be used inside the heat map, just press Shift Tab. So in order to check number of parameters used in that particular function, you can type Shift Tab and press this plus button. So here you can see all the parameters which are default parameters for this heat map. Let's close this. We are not using any other parameters. Let's press Shift Enter. Let's see the heat map. So this is in-hospital death, which is our label. Here we can see that gender is not that much correlated with in-hospital death, and GCS is negatively correlated, and BA1 is positively correlated. So let's remove columns which are not very much correlated. So first we have gender, which is not that correlated, and again we have cholesterol, which is 0.008 correlation. It is neither negatively correlated or not positively correlated. Then we have HCT, which is 0.009, and we have ICU type, which is 0.006. It's also not that highly correlated. And then we have height. This is also not highly correlated. So let's remove all these columns from our data set. Now let's again separate our features and labels. So we'll create new data frame, and here we are dropping our labels column. So in hospital death is our label column. Let's create new data frame with the name underscore df is equal to new is our original data frame name. So new dot drop in hospital underscore death. So we are dropping this column from new, and axis is equal to 1. Now new underscore df dot shape to see the shape of our new data frame. Let's execute this. I'll press Shift Enter. So now we have 3999 rows and 42 columns. So again let's assign it as df. So df is equal to new df. So our data frame name is df. Let's execute this. I'll press Shift Enter. Let's remove these 5 columns from our features data frame. So for that, data frame df is equal to df dot drop these 4 column names. We have gender, cholesterol, HCT, ICU type, and height. So we are removing these 5 columns. Just press Shift Enter to run the cell. Now we need to do feature scaling. We need to scale our data. So for that, we need to import a library which is minmax scaler. From sklearn.preprocessing, import minmax scaler, which will import our library. Then call that library. Scaler is equal to minmax scaler, and our feature range is equal to from 0 to 1. Now df is equal to scaler dot fit underscore transform df. Now let's run this cell. So first we have called our feature scaler, and then we are doing fit and transform on our data frame. So when we apply fit and transform, it fits the feature scaler on our data frame and transforms it then and there. Let's execute this. I'll press Shift Enter. So we have successfully completed feature scaling. Now it's time to create our deep learning model. So X is equal to our features data frame, Y is equal to our temporary array which we have created previously. So let's see the shape of our X and Y. First let's run this cell. Now let's run our shape cell. So here we are printing shape of our X and shape of our Y. So after removing these columns, we have 399 rows and 37 columns in X and 3999 rows and 2 columns in Y. Y is our labels and X is our features. Now let's split the data set into train and test set. We have already imported train test split from our sklearn.preprocessing. So X underscore train, comma X underscore test, comma Y underscore train, comma Y underscore test is equal to train test split. Here we need to give X our features and comma Y which is our labels, comma test size is equal to 0.2. So this means we have 80% training data and 20% test data. Let's run this cell. I'll press Shift Enter. Now let's print the shape of our X train, X test, Y train and Y test. So in X train, we have 3199 rows and 37 columns, and in X testing data, we have 800 rows and 37 columns, and for Y training purpose, we have 80% of total data, which is 3199 rows and 2 columns, and in Y testing data, we have 800 rows, 2 columns. Now let's import all the important libraries for building our neural network. And from keras.models, import sequential. From keras.layers, import dense, dropout, and batch normalization. And then import pandas as PD. And from sklearn.model selection, import train test split. And from keras.utils, import np underscore utils. And from keras.optimizers, import rmsprop, Adam. Let's run this cell and then we'll start building our model. So I'll press Shift Enter to run this cell. Let's start building our ANN model. So here model is equal to sequential. So sequential model means we are describing the layers in sequence and we will describe it sequentially, which is layer by layer. So our first layer is model.add dense 64. Input dimension is equal to xtrain.shape of 1, comma activation is equal to relu. So here in first dense layer we have 64, which is 64 neurons, and here our activation function is relu. So dense means a fully connected layer, which is what we are using here. A fully connected layer with 64 neurons. And then in another line we have model.add dense 128 and activation is relu. So here we are giving dense layer with 128 neurons and activation function is relu. So here we don't need to give input dimension because our keras will take the input from the previous output. So from the first layer output, it will take it as input in the second layer. And in third layer, we have 196 neurons and activation function is relu. And in fourth layer, we have model.add dense 196 with activation function as relu. And then we have model.add batch normalization. The batch normalization layer can be used to standardize inputs before or after the activation function of previous layer. Our model will give better performance when we add the batch normalization layer after activation function of previous layer. And then we have model.add dense with 256 neurons and activation function is relu. And finally we have final output layer, which is model.add dense with 2 neurons and activation is sigmoid. So finally we need to compile our model, and model.compile optimizer is Adam, and here we are using learning rate is equal to 0.0005 and loss is binary cross entropy and metrics is accuracy. So let's run this complete cell. I'll press shift enter. So it will give summary of our complete model, because we have printed here model.summary. So here the total parameters are 126,378 and trainable parameters are 125,986. Now let's fit the model. So we are saving our model in history. So history is equal to model.fit to xtrain, ytrain, and number of epochs is equal to 15, batch size is equal to 128, and our validation data is xtest and ytest. So we are fitting our model on xtrain and ytrain, and we are validating it on xtest and ytest. Let's run this cell. I'll press shift enter to run the cell. So now our model is getting trained. So training has been successfully completed. So first we had 0.47 loss and accuracy is 82%, validation loss is 53 and accuracy is 86. Okay. So by the end of 15th epoch, we got loss as 0.27 and accuracy as 88, and validation loss is 0.38 and validation accuracy is 87%. Now let's evaluate the performance of our model using accuracy, loss and confusion metrics. So all the parameters of our model are stored in history. So let's check the keys of our model. So let's print this. So we have validation loss, validation accuracy, and loss and accuracy. So we have training loss and training accuracy, validation loss and validation accuracy. So let's plot a graph to check our validation and training accuracy. So to plot our graph, we are using a matplotlib library. So initially we have imported matplotlib.pyplot as plt. So now we are using the plt.plot in order to plot accuracy graph. So first we are taking history.history accuracy, which is our training accuracy, and plt.plot in parenthesis history.history validation accuracy, which is our testing accuracy. So let's give a title as model accuracy. For that we need to type plt.title model accuracy, and y label is accuracy, x label is number of epochs, and plt.legend. plt.legend creates a legend with the data of train and test. It gives colors to train and test graph, and the location is upper left. So it will show the train and test name in the upper left corner. And to show our graph, we use plt.show. Let's run this. I'll press shift enter to run the cell. So the title of the graph is model accuracy. So blue color line is training set and orange is tested. So with the number of epochs, so total we have 15 epochs. So with the increase in epochs, our model and accuracy has also been increased. And even in validation, with the increase in epochs, the validation accuracy has also increased. So similarly, let's create a validation loss and training loss. So just copy the above code, and similarly, instead of accuracy, here we have loss, and instead of validation accuracy, we have validation loss. And here also change title as model loss, Y label is loss, and X label is epochs. So let's run this cell. I'll press Shift Enter. So here the title is model loss. Our loss has gradually decreased for both training data and validation data. Now let's import confusion matrix. Confusion matrix is a summary of prediction results on a classification problem. The number of correct and incorrect predictions are summarized with count values and broken down by each class. This is the key to confusion matrix. The confusion matrix shows the way in which your classification model is confused when it makes predictions. It gives us insight not only into the errors being made by our classifier, but more importantly, the types of errors that are being made. So I'll show you how our confusion metric works. First, let's import our confusion matrix from sklearn.metrics, import confusion matrix, and now let's make prediction. So pred equal to model.predict x test. Predict is equal to np.argmax in brackets pred comma axis is equal to 1. So y true is equal to np.argmax y test comma axis is equal to 1. So in pred we have predicted value of our y, so which is y pred, and in y true we have original y values for the given x. Let's implement this. I'll press Shift Enter. Okay, now let's print the confusion matrix. So I'll bring this column out. Okay, so now CNF underscore matrix is equal to confusion matrix between y true, which is y original, and this is prediction pred, which is y predicted. Let's print the confusion matrix. So as all survival and deaths are not equal, we can't use validation accuracy as the sole criteria for calculating the model performance. Here the precision is more important than recall, particularly for this dataset. So in this confusion matrix, we have 685 true positive and 6 true negative, which are correct predictions, and then we have 98 false negative and 11 false positive. So these are correct predictions and these are false predictions. Now let's print the accuracy. So here we have comparison between y original and y predicted. So accuracy score y true comma y pred. Let's print this. I'll press Shift Enter. So here we got accuracy of 87%. So let's see the loss again. So this model has loss of 0.27 and accuracy of 0.88. Loss of 0.27 and accuracy of 88%. So this is the maximum accuracy this can reach with the above size of data. So the size of data is very less. These model can be successfully used for predicting mortality in ICUs, but then one should keep in mind that these values are just predicted values and predictions can be wrong. To increase the accuracy of any machine learning model, we need lots and lots of data. So with the available data, we got an accuracy of 88%, but we didn't have enough data for testing purpose also. So this model is good, but in case of medical and health industry, we should have lots and lots of data because it's very risky. We should not take risk with the patient. Thank you. See you again in the next project.